That's probably why. It is the hardest of the bunch, but there is at least one problem that I decided after most of you got it wrong. I was like, you know what? I probably should have, we didn't really go over that well. I don't know you had any homework on it. So we'll talk about it right now, but it's this one right here. This is number 7, B. Let's see, 3 over n plus 2. Let me go to the bottom and just do this one real quick. As always, though, if you do, so here's what I did. After grading everyone, I was like, you know what? That's ridiculous. I should not have, I don't know, felt bad. So I basically gave everyone 4 extra points because that problem was worth 4 points. The maximum you would have lost is 4 points. So if you got any points, if it was anything other than a -4, you got bonus points for whatever you wrote. And some of you got it right. Well done, by the way. So I do remember talking with at least, I can't remember who it was, but someone came to my office the week before and was like, how do we do these telescoping things? And I was like, okay, here it is. So at least someone knew. I don't know if you got it right, if you were that person. But anyway, let's just do this really quick. 3 over n. Sorry, that's a minus, isn't it? Minus 3 over n plus 2. This is just one of the types of series that I don't know, we were supposed to cover maybe, but maybe we didn't. And so the way that this works is you could combine those into a single fraction, of course, and you'd get some weird expression. But the interesting thing, yeah, I think it's like, I don't know what you get, 6 over or 9 over n times n plus n squared, I don't know, n squared plus 2n. Doesn't matter. What matters is that since this is in this form, what we could do is we could just write down the terms. So this is going to be S1. So remember, these are partial sums. So this is the partial sum with one term. Let me just see if I can make things a little bit less right up here. Good enough. Oh, who's calling? No, sorry. Yeah. I told him not to call until 10:20. Come on, George. Okay, well, he'll leave a message. I guess he's on the West Coast, I think, so I think he's confused about times on the East Coast. He's trying to figure out mortgages. I mean, it's been years since I've had to move. But anyway, getting back to this. So this is 3 over n plus 1. So there it is, 3. Okay, so there's S1. That's the first partial sum. Then we'll write S2, and you'll hopefully see why we call this telescoping. So remember, no one lost any points. If anything, you gained points on this one. So this is going to be 3 over 2 minus 3 over 4. So you see what I'm doing here is I'm just writing down the terms. So if you put n equals 1 into this, you get this. Here's 1, here's 2. So what do we get when we add up the first 2 terms? So far, so good. Let's add up the first 3 terms. Now, this isn't the way that I would solve this if I were doing it on a test. I'm just trying to show you why we call it telescoping. So the third partial sum, 3 over 1 minus 3 over 3. That's the first term. Second term, 2 minus 3 over 4. Third term, 3 over 3 minus 3 over 5. I think you're probably seeing the pattern here. Let's write down let's just skip up to the 10th one. 3 over 1, 3 over 3. Give me a sec here. 3 over 4, 3 over 3, 3 over 5, 3 over 4, 3 over 6. I know. I should have picked a smaller number. That's okay. 3 over 7, 3 over 6, 3 over 8. Am I doing okay so far? 3 over 7, 3 over 9. I'm sick of doing this. We're going to change that. This isn't S10, it's S7. Okay, but you get the picture, is that there's a nice, easy form that you could keep going if you want to. Now, here's the cool thing about this, is that you'll notice that up here, when I was doing this, nothing cancels here. Nothing cancels, nothing cancels, so no canceling. But when we look at S3, something cancels. Check it out. This one right here cancels with this one, because this one is negative and this one is positive, and because arithmetic is associative and commutative, you can just move those around and just 3 over 3 negative over there, this one's positive. Now, I skipped a bunch of them, but when we go to S7, you'll see that a whole bunch of stuff cancels. Oh, not that one, sorry. This one, very exciting. Look at it all. It all cancels. That's what's meant by telescoping, is that all of this stuff cancels, and this thing that was a huge sum just collapses down like one of those telescoping cups that you bring camping with you, or a child's telescope. It crunches down, and all you have is the beginning and the end. So in general, you can probably figure out the pattern that S sub n is 3 over 1 plus 3 over 2, because this one, the 3 over 3 will cancel with this one, and so on. And then at the very tail end of this, you'll have minus 3 over n plus 1 minus 3 over n plus 2. Check it out. It's always this way. You have, for S7, you have 3 over 1, 3 over 2, and then minus 3 over 7 plus 1, which is 8, 3 over 7 plus 2, which is 9. Up here even, those two, both of them, you have 3 over 1, 3 over 2, and then this is S3, so you're subtracting off 3/4 and 3/5. Even this one, S2, you have 3 over 1, 3 over 2, and you're subtracting off 3 over 3 and 3 over 4. So we have a nice pattern. That's the formula. And now we just ask, what is the limit as n approaches infinity of S sub n? And that's going to be 3 over 1 plus 3 over 2 minus a couple of zeros. And so the final answer is 9 halves. 9 halves. There it is. So anyway, just some series you can find the sum. It's not all that useful for what we're doing moving ahead. So that's probably why I was like, let's just push that aside. I don't know. But anyway, it's kind of cool. So like I said, no one lost points for that. If anything, you got points. If you did anything, I was like, oh, I feel bad for you. And I only took off 3 instead of 4. I probably should have taken off 4, but I took off 3. And so you got a bonus point. And then some of you got 4 bonus points if you got it right, if you got that answer. Okay. I don't know what else we need to talk about. There's this, remember your basics. Remember the basics, I guess. And if you do have trouble with any of this, or if you want to complain, please stick around afterwards. I'm happy to talk to you about your particular test result. So what you see online, okay, so one last thing, is whatever number is at the top of this paper, you should have 4 more than that online. So if you go to Moodle, double check, like if you have like this person here, actually no one here, I'm just making this up. This person has a 79 at the top of their page, but when they look on Moodle, they should see 83. So that's the deal. So add 4 and you'll find the score on Moodle. Okay, so like I said, stick around if you want to. Afterwards, we'll have time, hopefully, to deal with this. We do need to move on though, so let's do this. So we're moving on to the absolute convergence and the ratio and root tests. So this, oh, come on, people. Kansas City now. Kansas City. Yeah, go away. Decline. Is that showing up there? Yeah, it's ridiculous. These people. All it takes is when I call them and I tell them I have class from 9 to 10 to write it down. Well, they aren't getting my business apparently. Okay, absolute convergence and the ratio and root test. You've already seen this sort of a term, this absolute convergence. At least some of you saw it because you're like, what does that even mean? So let me tell you what it means. You have some series, for example, this series, n equals 1 to infinity of 1 over n. And well, let's find out. Do you know, does that converge or diverge? So give it a, that's not what I'm looking for. Just a minute. Move this over here. So figure out, and the other one that I want to show you is this one. Here are 2 series that look alike, but one of them, that's supposed to be a 1 there. Just a minute. Oh, Superman showed up too soon. He'll show up, don't worry. And I was going to explain, but too late. He came a little too quickly. So take a look at those 2 while I get myself figured out in terms of our attendance. Tell me which one of those converges, which one of them diverges. Maybe they both converge, maybe they both diverge. And I'm going to get myself attendance done. Calculus, attendance. Okay. I think everyone who's absent is actually has excuses, interestingly. No, there's one person that does not have an excuse. Oh, well. Who else? Let me double check. Did I get everyone? Yes. Yeah, I got him. Don't worry. Allegedly sick. Just want to get it clear there. Okay. All right. Wait, that was like a HIPAA and a FERPA violation all rolled into one. Okay. Now that I've got that taken care of, let us randomize this class. Hunter, you know about this first one, don't you? Does that converge or does it diverge? It diverges. Do you have a reason? You don't have to if you don't want to. Yeah, power series, P equals 1. So this one diverges, power series, P equals 1, or you could call it the harmonic series if you want to be fancy. Harmonic series, which diverges. So yeah, but it is a power series, P equals 1, which is not greater than 1. For this to converge, it would have to be greater than 1. Yeah, greater than 1, sorry. Having trouble remembering the difference. Okay, next. Let's do this next one. All right, who do we have? Thomas. Thomas, what do you think of this one? Does that converge or diverge? It does converge. Do you have any reasoning behind your conviction that it converges? I can always pick someone else if you don't want to. Yeah, okay, everyone, other terms negative. We have a name for that. We have a name for that sort of thing. It's called an alternating series. And so this thing is an alternating series. Alternating. And so whenever you see an alternating series, you think, okay, does this thing, oh, come on, get back. So you think of the B. The B is 1 over n. Is that decreasing? Sure it is, because 1 over n, that's really easy. You can imagine the graph of that. It just decreases. So it's decreasing positive, and this thing alternates. So this, oh, the limit. The limit is 0. So we're all good with this. So I could even write this down. B sub n is decreasing, and the limit as n approaches infinity of B sub n is 0. So yes, this thing converges. Very nice. So finally, I guess Superman can show up here. My brother-in-law is really into Superman, and so years and years ago, he came and visited with my sister and sat in on a class. And ever since, I've just, I kept all these. So this is the class that they sat in on, just for fun. This is literally decades ago, so I keep revising this each time, I guess. But so Superman is going to pop in every now and then, just to warn you. So first off, absolute convergence. This back here, we say that this thing converges, but it doesn't converge absolutely. So absolute convergence means that if you drop the negative, if you drop the alternating part, it'll still converge. That's all we mean by absolute convergence. So here's the sort of definition, is that if you have a series and you think about what would happen if you got rid of all the negatives, made everything positive, does the new series, does it converge or does it diverge? So as long as the new series does converge, then we say that this is absolutely convergent. So absolute convergence just means that the series converges even if you get rid of all the negatives. I mean, alternating series, the test is so weak, isn't it? All you need to do is see that you're decreasing and going to 0. There's not much to check. And so there are a lot of series that converge if you alternate them, but don't converge if you don't have them alternate. So that's the deal with this. And actually, this plays into where we're going with this in terms of our stuff. So absolute convergence means that this converges as well. So that's in your book if you cared to look, but maybe you don't. So let's take a look at a couple of examples. So here's the first example. This series, does this converge first of all. So first of all, I guess we have to ask, does it converge? I think you can guess it does. But tell me why this converges. And then secondly, we want to know, does this converge absolutely? So first of all, does it converge? Or maybe tell me why it converges. And then, is it absolutely convergent? All right, let's pick a rando here. Andrew, you know that this converges, but can you tell me why it converges? It is alternating, very good. And you've gone through the alternating series test. Well done. So I'll just jot it down because you just didn't want to speak it all out there. So it's alternating series. And so number one, we have B sub n is 1 over n squared, which is positive and decreasing. Okay, that's not much space there. It looks terrible. And number two, the limit as n approaches infinity of B sub n is equal to 0. That's all you have to check. You just have to make sure that you can pull out the negatives, basically, and what you're left with is a decreasing positive sequence that goes to 0. Okay, very nice. So let's move on. Oh, I want to know if this converges absolutely, yeah. Why was I having trouble with that? I don't know. I'm annoyed by these people calling me, maybe. Okay, so yeah, I make phone calls and I say, don't call till after 10:20. Anyway, let's do this. Oh yeah. So here, so this is what we're going to do. Is this, so it does converge. So this converges, converge, but does it converge? Absolutely. So to do this, we want to know, does this converge? So 1 over n squared. Here we'll get Ben P involved. Ben Peoples, what do you think? Does that thing converge now that we've dropped the negatives? Wait, it does? Why? Oh, that's right, that P series. And you know that the P is bigger than 1. This thing converges. So P series. And so this thing converges absolutely. So this will be absolute convergence. I have to erase some stuff though, sorry, because there's another, whoops. Okay, well, apparently, yeah. Oh, no, that's already done. Okay, let's try this one. So, oh, we already did this one. Yeah, here's Superman again. So this one, is this absolutely convergent? This is a no. No, not absolutely convergent. And because we've already done this one, this is the harmonic series or the alternating harmonic series. So if you put the pluses and minuses in, this does converge. But if you get rid of them, it does not converge. Let's see, do I care about this next thing? I probably should put it up there just in case. Okay, oh, just definitions. So conditionally convergent is not absolutely convergent. So I'll write this down. I think all you really should write down, these are a lot of words, they're in your book, but you could do this, that this series is conditionally convergent. And this one is absolutely convergent. There we go. So you have those two series that we just looked at as your sort of examples. One conditionally convergent because if you drop the negatives, no longer converges. This one absolutely convergent because it works either way. Yeah, don't worry, we're going somewhere with this that we care about, but for now it just feels like a game or whatever, trying to solve a puzzle. Okay, so we've got that. Let's do this one, see if this one works. Okay, so is this one convergent or divergent first? And then we'll deal with whether it is absolutely convergent. So does this thing converge? Well, that's kind of hard to say. And the reason is that this thing does not alternate. I know, sometimes negative, sometimes positive. The problem is that if you take your calculator and you start doing cosines, let's see, is this, yeah, here it is. Yeah, it has positive and negative terms, but if you use your calculator, you find that the first term is positive, this term is negative, this one's negative, the next one is negative, but then you have 3 positives, and so sometimes you get 2 positives in a row, sometimes 3. I don't think you have more than 3 in a row, but it alternates irregularly. So it's not an alternating series. However, if a series converges absolutely, then it will also just converge. So if this thing converges absolutely, then it converges. So let's do the absolute convergence. So what we'll do is we'll take this thing and we'll imagine dropping the negatives. So if we can get rid of this alternating business, this irregular alternating, here's what this would look like. Sorry, I got to get rid of my my absolute value sign looks terrible. Oh, now my pencil stopped working. Come on, what's going on here? Let's go over here. It's working over here. Okay, we'll do it over here. N equals 1 to infinity. I'm going to do this cosine of n. Do the absolute value, because that's the problem, right? That's the part that is that's sometimes negative, sometimes positive. This, you can tell whether this converges or diverges pretty easily. I'll give you a minute. See if you can figure it out. Does that converge or diverge? And then I'll find a volunteer to tell me. So try to come up with your reasoning. Oh, you're not here. All right, Eli, do you know, does this converge or diverge? And maybe you just have like a hint, like, oh, I think it does or doesn't. It definitely converges. Why do you know? It's like 1 over n squared. And so let's use the direct comparison test. And the direct comparison test is dangerous because you have to make sure you get the little alligator pointing the right direction. So Eli said that this is like 1 over n squared. And I want to know, do I put this direction or this direction? Which of those am I going to put between these? Or better yet, let's see if I get rid of this one. Just a minute. I could just take this one and rotate it. Can I rotate? Sort of. Yeah, so which way does it go? Or I'll just leave it like that for now. So is that bigger or smaller than 1 over n squared? That's your next chore. And we'll get Darren to tell us. Which one's bigger, the one on the left or the one on the right? The one on the right is bigger because, as Darren knows, the cosine is never bigger than 1, right? 1 is the very biggest it could be. So technically, I suppose I should actually have this, but whatever. That means that this sum will be less than this sum. And as Eli said, that one is a p-series that converges. So getting back to this particular series, it converges absolutely, which means it also converges just like that. If you have I don't know what it converges to, but this thing converges because that one converges. So whenever you have something that absolutely converges, then for sure the series converges. So that's where this is important, is because there are going to be series like this that are hard to figure out, but then if you just work on their absolute convergence, that's going to be a lot easier. And we're getting back to functions. Oh, discard, discard, keep, discard. Okay, whatever. Well, there's Superman again. Okay, so here we are to this. Okay, very nice. So here's 2 for you. And then we're going to shift just slightly. So this, actually, we're doing 2 things today. We're doing this absolute convergence business, and then we're going to do the ratio test. It's very exciting, the ratio test. But go ahead and figure out if these converge or diverge absolutely or conditionally, and so on. Here, I'm going to make a little grid here. Whoops. Sorry, I got to go to Notability to do this. Okay, I've made a little table for myself. I'll show you what I drew. It's not the best, but I thought this would help sort things out because we have to ask all of these questions. So the first question we're going to ask is, if we leave the -1 there, does this thing converge? So leave the -1, it alternates, great. Does that converge? Then drop the -1. Notice that this is that without the -1 business. Does that new thing converge? And then we'll be able to label these as either conditionally or absolutely convergent. All right, Christian, what about this first one? If we leave the -1 there, does this thing converge or diverge? Very nice. It converges because you know that the alternating series test, that's what we're going to be using with all of these that alternate. So alternating series, you're going to have the b sub n is 1 over the 4th root of n, which is greater than 0 and decreases. And the limit as n approaches infinity of b sub n is equal to 0. And so this thing converges. Very nice. All right, now let's drop the -1. Drop the -1. I'm going to just jot it down over here to make sure that you see, in case you're like, oh, what do you mean by dropping it? I'll show you. Get rid of the negative part. So let's take a look at that one. Carson, you know about that one, don't you? Does that converge or diverge? It diverges. Why does it diverge? That's right. P is equal to 1/4, which is less than or equal to 1. So this diverges. Okay, so if it converges, but when you drop the negative, you're diverging, then we're going to call that conditionally convergent. Converge. Okay, whatever. All right, now let's try this second one. You can probably guess this is different, but we'll find out. Let's go through the motions, though. So Hayden, what do you think of this when you have the negative? Does that converge or diverge? Okay, so let's let me put that in here. Whoops, I didn't mean to do that. Hold on a minute. Can I just get the, I just want the stuff that I delete this. Oof. I guess there's no way to, I was trying to cheat and copy just the stuff. So this is an alternating series. This is going to be b sub n is 1 over n to the 4th, which is greater than 0 and decreasing. And the limit, b sub n is 0, so this thing converges. Very nice, Hayden. Sorry it took me so long to write down your thoughts. All right, let's get the next one. So what if we drop the negative part? So what do we get now? You were here, not here. Karen, what do you think? What if we drop the negative? Let me write it down like I did the one above. This is n equals 1 to infinity of 1 over n to the 4th. Does that converge or diverge? It converges. Why do you know that that converges? It's a p series. P is 4, which is greater than 1. So because this converges no matter what, we call this absolutely convergence. There we go. Very nice. All right, any questions about that? Okay, so what we're going to be doing, let me get this here. Just a minute. Just trying to think, how am I going to do this? How about this? Yeah, there's a little word down there apparently. Let's do it this way. I'll make up a series here and we'll see how things go. N equals 1 to infinity of 1 over n to the 1/4 times 2 to the n. That's, well, whatever. That's fine. It's fine. I know that you probably know whether this converges or diverges, but I just want to point out something about this, that this is kind of a hybrid of things that you're familiar with. You're used to the P series, you're used to geometric series, but this is kind of a mashup of both a P series and a geometric series. So how do we know whether this converges or diverges? Oh, I know what I could do to make things even more confusing is, no, I don't want to make it confusing yet. So here's the idea that one idea, there's a couple of different ideas, is if this were a geometric series, you would compute R, and if R was between 1 and -1, then you converge. Now, what is R though? I mean, here, let's just take a look at, let me get an example for you. Suppose you have this series. So here's this, just a minute, plus, let me give this, how about 6 over 4? Give me a minute here. Yeah, that was dumb. It should be 3/2, shouldn't it? Hold on a minute. 3/2. 9 over 8. Okay, you see what I'm doing here? Just a minute. 27 over 32, ... So I want to know, what is R? What is the common ratio for this? So this is geometric, by the way. We'll get back to the non-geometric in a minute. So find R. I know you're waiting for me to pick someone. People that aren't here. Christopher, you know what R is, don't you? It is 3/4. How did you figure that out? Okay, that's one way to think of it. Also, you could think of it this way. You could take the 9/8 and divide it by 3/2, and you should get 3/4. So this is true for any pair of successive terms. 27/32 divided by 9/8 is also 3/4. In fact, if I did this, a sub n plus 1, and divide it by a sub n, I get 3/4, no matter where you are in this series. So pick any point, common ratio. What do you think? Did I mess up? Let's double check. Maybe I messed up. So let's do the first two. 3/2 divided by 2/3. Oh, interesting. I didn't get, I got 9/4. Well, that's all right. Yeah, so this is we're good from here over. So, yeah, I mean, honestly, when you're evaluating series, really the first finite number of terms don't matter. What matters is what happens for the infinite number that's here. So as long as, yeah, I messed up. It should have been, I guess, just 2. There, that make you feel better? It makes me feel better too. So we do that. Now it's 3/4. Very nice, thank you. But anyway, if you take successive terms, you get the common ratio. So here's the idea behind the ratio test. The ratio test, you're going to take a similar thing. You'll do a sub n plus 1 over a sub n, and you're going to ask yourself, is this close enough to a geometric series to say that it converges? So what do we mean by close enough? Well, here's what we mean. We mean this, that if you take that ratio and you do the limit as n approaches infinity of that ratio, is that less than 1? And if it is, we're going to say that this converges. Essentially, what this is doing is you're doing a limit comparison test of a series with itself, kind of. So it's another way of thinking of it is that you're trying to figure out, is this close enough to a geometric series to say that it for sure converges. So we won't go into the proof. If you really want to see the proof, you'll have to look in the book, but that's how this kind of works, or the way that I think of it. Let me put this up here with this. We've already done that. So here it is, ratio test. So I know lots of words, but here's the main thing that you need to know is you're doing this. I'll highlight all you should write. I would not write anything but this because this comes right from your book. You're going to write this, and then you're going to write this, and then you're going to write this. So that's the first thing to write, is that if the limit is less than 1, then you converge. You converge absolutely, in fact. And then I wouldn't necessarily, I mean, if you really want to, you could write something about letter B here, but it's in your book. I guess what I think of is that this part is the important part. If your limit is bigger than 1 or infinite, then you're diverging. And then if it equals 1, then we don't know. So sadly, if this limit equals 1, then we're lost. So let's go back. I know it's going to be annoying to you, but I'm going to go back to the Notability to do that one that I wrote down. I'll come back to this slide in just a minute. So let's just do this real quick. So I want to do this one right here. I want to see, does this converge or diverge using this ratio test? So I'm going to make a little bit more room down here. Okay, so here's how I would do this. You start by writing down a limit. So you're going to do the limit as n approaches infinity. And then here's the important part, is I'm going to put that thing on the bottom. That thing goes on the bottom. 1 over n to the 1/4 times 2 to the n. And what goes on the top of this fraction, and this is a nasty fraction here, what goes on the top is you just change all of the n's to n plus 1. So that's what I'm doing. That's the limit that I'm doing. Okay, bear with me. This is going to involve a little bit of algebra. The first step, though, is always going to be pretty much the same, and that's this. Flip the bottom and multiply. So hopefully that doesn't shock you, is that when you divide fractions, you flip the bottom, multiply. Now I'm going to do a little bit, I'll do this, I'll take my time with this. And honestly, if I ever do something, or if you're like, if one of your friends does something and says, oh, it's this, and you're like, I don't know how it got there, let me know, stop me, and we'll take our time. Okay, so this is going to be the limit as n approaches infinity. I'm going to do two things. Well, no, I'm going to do one thing. I'll do these one at a time. Yeah, this is a bit overkill to write it out like this. But I just want to show you that it is just basic algebra. So take your time. If you need to, you can write out all of this stuff. Now I think it's time that we can do our limit. So Landon, let's do the limit of just this fraction here. What's the limit as n approaches infinity of that fraction? So you got n over n plus 1. What was that? So we got the same coefficients. So It's into the first. So it's polynomial over polynomial. So this is the trick where you take the leading coefficient. What's the coefficient here? And what's the coefficient here? Oh, yeah, yeah. So it's 1. 1 over 1 is 1. Very good. So 1 over 1 is 1. So let's see, this limit. Oh, no, I don't need to write limit anymore. I'm going to get 1 times 1/2, which is 1/2. 1/2 is less than 1, and so this thing converges. So up here, this thing converges, converge, absolutely. It's absolutely convergent. It looks wrong. That's all right. Okay. Okay, let's do a few other examples so that you can do it yourself. Okay, we don't need to do that one. That one's too easy. This one's more fun. So is this thing absolutely convergent? By the way, this one is convergent. So n cubed over 3 to the n, the limit as n approaches infinity is 0. But I'm going to know, does it absolutely converge? So you're going to set up your ratio. What do you think, Hayden? Oh, sorry. Yeah, I guess I promised I would pause again, but is this one you mean? You mean this one? Yes. Okay. That's it. All right, I'll wait. Sorry, I got a little excited. That's right. Between, well, yeah, less than 1, because this is an absolute value, so it's never going to be negative. So yeah, anything less than 1 means that you're converging. Absolutely. Absolutely converging. All right, we'll go on to this example here. Whoops, not that one. This one. Nope, not that one. This one. All right, so you want to set up your ratio test. You're going to set up a ratio. So that's your first chore. I'll give you a minute, and then I'll pick a volunteer. Yeah. All right, let's see how we're doing. So I just want to get the ratio. So tell me what to put in my ratio. I'll get it set up. All right, Caleb, what am I putting in this thing? Like what goes on top? So so on top we're going to put here, I'll just remind you, the top you put a sub n plus 1. On the bottom you put a sub n. So what's going to go on the bottom maybe? We could do that one first. Okay, yeah, into the third. Yeah, okay, 3D n, very good. And I mean, just for completeness, I could put that there. You know that that's going to go away, but there it is. Okay, very nice. So we've got the bottom. Let's get the top figured out. Maggie, do you know what goes on top? All right, 3 to the n plus 1. Very good. And just for fun, I'll put this here. It's going to go away in just a minute. But technically, you put it all up there, and then we'll deal with the negatives in just a sec. Okay, so we've got this big, ugly, nasty thing. All the negatives are going to go away because we're doing an absolute value. The absolute value of -1 is +1, so that's going to disappear. But I only put it there because, just to, I guess, to remind you that if there was like a cosine of n or something like that, you'd want to keep track of what you're using the absolute value on. So I might write it like this. Just a minute. Limit n approaches infinity. So this will be just a sec. I know this is kind of overkill. And if you want to skip this step and just go to the, get rid of the negatives right off the bat, that's fine. 3 to the n, there it is. Wow, yeah, so all of this, that's just 1 over 1, because -1 to any power is either positive or -1. But anyway, let's get down to here. So let's see, I'm going to clean this up just a bit, and then you're going to tell me what to do with it. So let's see, this is going to be n plus 1 cubed over 3 to the n plus 1. So the way I always think of this is you've got the denominator, you're going to flip this and multiply by the numerator, so that n cubed on the bottom stays on the bottom. The 3 to the n on the bottom ends up in the top. Now we need to simplify this as much as we possibly can. Oh, I left off my limit. Give me a minute. Let's write down limit. Okay. All right, let's see who wants to do this. Braden does. Braden, tell me about simplifying this. Is there anything you can do to simplify it? Oh, yeah, that would make sense, wouldn't it? Yeah, separate. What are the two fractions you would have? Okay, I'll just do that. And then what's the other one? Very nice. Beautiful. Yeah, so that's perfect. So so there's some canceling that happened here, and then this thing is its own fraction. All right, so now we just need a limit. You would know it, but you're not here. I guess we've looped around. So I keep getting repeats. Carson, I guess we're going to get you again. Carson, what's the limit of this thing? Yeah, 1/3 times 1. Very nice. 1/3 times 1, and that happens to be less than 1, and so this thing converges. Converges absolutely. Absolute convergence. Very nice. All right, let's see what else we have here. Okay, we've got a bunch of these. Let me just see if there's anything really good. Oh, that one's interesting. Yeah, we should do that one. Yeah, let's do that one. That one's fun too. Let's do this one first. So this one's good. So let's set this up. We'll do it pretty quickly though. So I'll give you a minute to jot it down. See if you can write down. So what you're going to do is you're going to write down your limit. Just a minute. So you're going to write down the, whoops. Let me change this. Okay. Yeah. So try to get two things. First of all, the basic, plugging in n plus 1, and then try to simplify it some. Just realized I need more room. All right, you've probably just had time to copy this down, but it's not that complicated. You're going to put n plus 1 here, n plus 1 factorial there, and then on the bottom, negative n times n factorial. Okay, so I need to take a little bit of a sidebar, if you will. So go down here for just a sec, and let me point something out, that n plus 1 factorial is equal to n plus 1 times n minus 1 times n minus 2, and so on. But that is just n factorial. So n plus 1 factorial is just n plus 1 times n factorial. I could do this with other things, like if I had 2n plus 1 factorial, that's just 2n plus 1 times 2n factorial. Oh, let's just do one more, just so you can sort of see the pattern. If you have like, how about 3n plus 2 factorial, that happens to be equal to 3n plus 2 times 3n plus 1 times 3n factorial. So I just wanted to point out that factorials, like 10 factorial, let's just do 10. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same as 10 times 9 factorial. So you can get kind of, shorten the stuff. So I wanted to point that out when you're looking at this, thinking, how in the world am I going to simplify this? It's because of properties like that. And these things come up quite a bit because factorials show up a lot in the series that were going to be actually useful, the useful series. So let's go ahead and use those. So this is going to equal, okay, so when you're dividing here we go, let's do it this way. This is going to be negative n plus 1 minus negative n. When you're dividing two exponentials, and you might have no problem with this, but I just want to point out, when you divide two exponentials, you subtract the exponents. So there's that. I'm just going to write n factorial down here, n plus 1 times n factorial up there. So check that, make sure that that makes sense. This might not be exactly how you would do it. If you were simplifying, I'm just doing it the way I like to, or just the way that kind of popped into my head. Now let's simplify a little bit more. You can see that these things are going to cancel here. So the factorials cancel, and you can also get rid of some of the exponents. So this will be the limit as n approaches infinity of e to the negative 1. I believe the n's cancel, times n plus 1. Does that work? Is that correct? I think that's right, because you have e to the negative n minus 1 plus n. So the n's cancel, and you're just left with this. Let me do one more thing, and then I'll ask what this limit is. Just shove that e down there where it belongs. All right, I'm pretty sure you know what this is. Michael H. Michael, what do you think the limit is for this thing? It is infinity. You're right. You're not fooled by the e. Very nice. So that is infinity. That's definitely bigger than 1, isn't it? Because this is definitely bigger than 1, this thing diverges. So that series diverges. So that's the use of this. Let's do one more. I see that we're almost out of time. So give me a sec. Let me find another example. Let me pick a good one. That one's boring. That one's kind of fun. Ooh, I like that one. Let's do this one. Let's do this one. This is a good one. It's kind of boring. Well, sorry. I know what the answer is, so it's boring to me. Well, I'm going to change it up. Let me do one where, well, I know what the answer is, but we'll do this one. Let's do this. So 4 to the k over 2k factorial. Let's do that. Oh, let's make it more interesting. Negative 4 to the k. That's better. And k is going to go from, doesn't matter, 0 to infinity, because 0 will be fine. So does that thing converge or diverge? See if you can set that one up. That's a nice hard one, but we're gonna do it. It's gonna be okay. All right, well, given the time, I'm going to blow through this relatively quickly. We'll see how you did. Stop me if you have questions. On top, I'm going to plug n plus 1 into this series term. So negative 4 to the n plus 1 over 2n plus 2 factorial. You might say, wait a minute, n plus 1, but bear in mind, this is 2 times k. So if you change the k to n plus 1, you're going to get 2 times k plus 2 times 1. So that's 2 times n plus 1 will be 2n plus 2. Here, I'll write it down. 2 times the quantity n plus 1 is 2n plus 2. Just in case you're wondering where'd that 2 come from. On the bottom, I'm going to just replace the k's with n's because I don't like k. So I know I am discriminating against k. I don't care. You might be more comfortable with the k than I am. Okay, let me clean this up a bit. I think you know what's going to happen with the negatives, but I'm going to be more just careful with it. Negative 4 to the n plus 1 times 2n factorial over negative 4 to the n times 2n plus 2 factorial. Okay, so let me just pause and make sure that everyone's happy with what I just wrote. Does it look okay? So I know I kind of did 2 things there, but remember, you're going to take the bottom fraction, flip it, so this gets up here, and this stays down here with that 2n plus 2. All right, let's finish it up. 1 minute. Oy. Okay, that's okay. So this is going to be the limit as n approaches infinity. We're nearly done. So this is going to be negative 4 times 2n factorial over 2n plus 2, 2n plus 1, 2n factorial. Those will cancel, and you're going to be left with 0. Because you have a bunch of stuff down here, just negative 4 on the top, which I know absolute value, you'll have positive 4. You could change that if you want, but the important thing is that this is 0, so this converges. That thing converges. It absolutely converges. So it absolutely converges. All right, do your best with the homework for tomorrow. It's going to be a little bit of a challenge. This is hard stuff. So give yourself time. Be patient. Yes, Americo. Wait, where? Which one? This one right here? Right here? I got it by taking n plus 1 and plugging it into there for k. So 2 times the quantity n plus 1 is 2n plus 2. All right, stick around if you want to complain about your test, or even if you just want to talk about your test, not complain. I'm going to stop the recording in case